Good day, Dr. Andy. I am Brian, and today I am representing Group P2 for our fieldwork survey findings, which is to compare two different ways to study wildlife, which is mist netting and camera trapping. Our fieldwork was conducted at Sfera UMS and KK. So, to study the wildlife at these locations, we used two main approaches, which is invasive and non-invasive. For our invasive method at Sfera, we used mist netting to safely catch, check and measure small birds up close. For our non-invasive method at Tipar, we used camera traps, and this allowed us to take high-quality photos and videos of shy animals without disturbing them or making them scared of the traps. Our fieldwork took 5 days to complete. On the first day, we prepared the sites, cleared paths for the nets and set up the cameras. On day 2 and 3, we did active monitoring, checking the mist nets every 2 hours from 6 a.m. to 6 p.m. And on day 4, we analyzed the data, calculated the biodiversity indexes and mapped out the species. Finally, on day 5, we took down the equipment and collected all the data. For the mist netting part at Sfera, we used nets that were 3 meters high and 9 meters long. We placed them 1 meter above the ground across animal trails and forest ridges where birds usually fly. With our demonstrator, we kept the nets open for half a day from 6 a.m. to 6 p.m. for 5 days. To make sure the birds did not get stressed out, we checked the nets strictly every 2 hours. To measure the bird variety, we used two formulas. First, our Shannon-Weiner index came out to 1.550, which means we have a decent variety of bird species here. Secondly, the Simpson index was 0.905. This high number shows great species evenness, meaning there is 90.5% chance that two random birds that we catch will be from completely different species at Sfera. In total, our nets caught 7 birds from 5 different species and families. The two most common birds were the Asian red-eyed bulbul and the Malaysian pied fantail, making up about 28% of the total catch each. The crimson sunbird, oriental magpie robin and orange-bellied flowerpecker made up 14% each. This means for the most common species we caught about 3 birds for every 100 hours the nets were open. Next is the camera trapping calibration at Tipar. We strapped the cameras tightly to tree trunks about 30 to 50 centimeters off the ground, pointing straight at animal trails. We cleared away nearby leaves and twigs so the wind wouldn't cause false triggers for the sensors in the camera trap. And we set the cameras to take both photos and 10-second videos with a 1-minute delay in between, using 12 megapixel resolution with time and date stamps turned on. The most exciting find on our camera traps was the critically endangered Sunda pangolin. We caught it on camera looking for food late at night in the forest behind Tipar. Since this animal is highly protected, proving it lives on our campus is very important for conservation. We also caught the Malayan field rat quite often. It is a very common species that helps spread seeds and serves as food for larger animals. To compare the two methods, mist nets and camera traps, mist nets are great for catching flying birds and letting us measure them, but it will stress them out a little bit. For camera traps, on the other hand, it is more passive because it absolutely causes zero stress on the animal and let us see exactly how animals behave at night. But we cannot touch or measure the animals physically like missed nets. Based on our findings, we have 3 recommendations for our campus. Firstly, because of the pangolin, we should stop using chemical pesticides near university farms at Tipar because that will reduce the termites and ants there for the pangolin to eat. Secondly, we should extend future studies from 5 days to 30 days. I know it is impossible, but this is just a recommendation to get better data across different seasons. Lastly, we should put up warning signs around the forest edge to keep people out and prevent illegal poaching. Even students can illegally poach the pangolin. Might be me. In conclusion, using both of these methods together gives us the best tools to protect and manage our campus wildlife. On behalf of my group, thank you very much for your time and guidance on this project, Dr. Andy. We are ready to take any questions or feedback you have about our data.